Okay, I'm I'm Jev Björsell. Thanks for coming to this Tez talk. Before we begin, show of hands in the audience, who's been attending ETH before this event? Okay, good. Welcome. So briefly, yeah, I'm Jev Björsell. I'm from ECAD Labs. We're a software development team based in Canada, largely out of Vancouver, BC. And we're the team that built and maintains Taqueria, which is a JavaScript TypeScript library for Tezos. Some people often refer to it as the Web3 library for Tezos. And it provides a lot of convenience for application developers for reading data from the chain. It also provides some neat abstractions. So to name a few, you can load a contract from the chain, and it'll give you an object with methods that correspond to the entry points of your smart contract. It does a bunch more stuff as well. So if you're new to Tezos development, and you'll probably cross paths with Taqueria, and if you need any help, do reach out. One of our other projects is called Signatory. It's a remote signer. Its main proposition is to sign operations for Tezos while keeping your keys safe. And it keeps your keys safe by storing them either in a hardware HSM, such as UBHSM, or in a cloud service, such as Google KMS, Azure, or Amazon KMS. So, but I'm not here to speak about these. These are just shameless plugs. I'm here to speak about Tackeria. So primarily, Tackeria is a developer tool suite for application developers. If there's anything you take away from today's talk, let that be it. So briefly, some of the things about Tackeria is that it's extensible by plugins. And I'm going to get into more of this later on. We're hoping to encourage best practices for Tezos development. And when I'm talking about best practice, I'm just talking about software engineering best practice, like testing, CI, CD, and so forth. So we want to lower the barrier to best practice, because developing in blockchain, it's a bit different. We don't have the same maturity in tooling as we do in traditional like enterprise development and so on. Not all of the things fit together, so there's some work we can help with there. And Tackeria also aims to assist with orchestration of your testing and your deployment pipelines. So before I go deeper into what Tackeria is, I want to do a little bit of context building. And if we look at the Tezos tooling ecosystem, and I presume most of you have been here yesterday, and you also took in the talks this morning, and it's probably not lost on you that there's a lot of tools in Tezos. So from the client libraries, you have choices amongst what languages to use, and there's many of them. So from JavaScript, TypeScript, through to OCaml, Python, Go, there's a lot of choices here. Indexers, like we have at least 3 layer 1 indexers, TZStats, TZKT, and Conse. And that's only the layer 1 indexers. There's also, on top of that, there's application or smart contract orientated indexers. And then wallets, there's too many to fit for bullet points, but yeah, Kukai, Temple, Galleon, AirGap, Umami. These are all different wallets that your users get to interact with. And then, yeah, testnets. So Tezos, because of this magical thing called on-chain governance, it upgrades its layer 1 protocol once every 4 months, and that's unprecedented in blockchains. That sort of pace is incredible, and this is wonderful for people choosing to build on Tezos, because you know that the blockchain is not going to ossify underneath you. You know that it has an upgrade path, and we have a really strong roadmap that Arthur laid out in the first talk for layer 2s and these rollups and so on. But there's a cost for that sort of cadence and those upgrading. So because we have all these upgrades, we have a lot of different testnets. We have protocol-based testnets known as like Kathmandu Net, IthacaNet, and so forth. We have a new testnet called GhostNet, which is a long-lived test chain. This is focused very much for application developers. And then there's also sandboxes and private nets. And then, of course, the not testnet, mainnet. And finally, high-level smart language languages. So there's a misconception amongst outsiders of the Tezos ecosystem is that you have to write your contracts in Michelson. It's not true. We have many high-level languages, even though some people do enjoy writing smart contracts directly in Michelson. Claude's in the audience here, he's nodding. Yeah, so we have Lego, SmartPy, Archetype, Indigo, and probably like the best name of a smart contract language in all of the blockchain industry, Scaml. With all of this, you know, as you can see, like the ecosystem is very rich and robust, and it's decentralized. That's good. Like there's a good diversity, and this is like practically a sales pitch for why you want to build on Tezos, because it has such a rich ecosystem. But it does have a cost as well. So we have so many choices and decisions to make. And so for a new developer coming into this ecosystem, or even an experienced developer, it's like, where do you begin? And where does that end? So first, I mean, you have to kind of choose your tools. What smart contract language am I going to use? What SDKs or libraries shall I use? And then you need to learn those tools. You have to learn how they interact, you know, the idiosyncrasies of those. And then, you know, if you're developing an end-to-end application that depends on a smart contract and these other entities, you need to cobble together some sort of like a development workflow for yourself. And, you know, through building, over the years, building Taqueria, I've seen it firsthand, and I've seen other teams build and reinvent that wheel of their workflow environment. So after you figure out your development workflow, you need to build. And then presumably, you're going to also write your unit tests for your smart contracts, your unit tests for your code, your integration tests for your smart contracts interacting with applications outside of smart contract. And then you probably want to run those in CI/CD. Now you have to figure out how to run all this stuff in CI/CD. And there's a lot of new trail to break here. After that, you may want to promote your application to a testnet, and you end up writing deployment scripts. And then, you know, time is probably going to be running out. And, you know, and this happened to me is like, I've given up on doing all the best practice. I was like, okay, I'm going to do it live. I will deploy this to mainnet manually, and I'll figure out the automation later. So this is why we built Taqueria. So Taqueria's aim is to bring together all these wonderful ecosystem tools from high-level languages, indexers, and all of these different pieces from the ecosystem, and to bring it into a cohesive, singular developer experience. We want to enrich the developer experience and encourage best practice. And some of the ways we're hoping to do that is by doing things like code generation, generating things like type definitions for your smart contracts, and also automatically generating integration tests, so to save you from having to write a lot of boilerplate. Tackery also hopes to assist with deploying to testnets and mainnet. I'll get more into that in a moment. And then also, we want to help you orchestrate these multi-step deployment needs, because it's more than just a smart contract. A smart contract just living on a chain isn't very interesting unless there's something that's built on top of it. And there's dependencies between your application, your smart contract, and other things like IPFS objects or other HTTP APIs. So a bit more about what Taqueria looks like in more practical terms. Taqueria operates in three distinct contexts. And primarily, I mean, it's a developer tool, so it's no surprise that it is a command line utility. And the command line utility is called TAQ, T-A-Q, so nice and short to type. Hopefully you can get that into your muscle memory. It's a self-contained binary that you can download onto your workstation and run with. And as Taqueria is a plugin-based system, all of the capabilities that you see in Taqueria are contributed via plugins that are provisioned within your project. So some of the basic things that you can do with the Taqueria command line is compile your smart contracts that may be implemented in different languages, such as Lego and SmartType, Archetype. And then it helps you deploy these smart contracts into a Sandbox or testnet or mainnet. And then it does Sandbox management. So you get to do tac start Sandbox, and you get a local Sandbox that starts up on your computer with minimal fuss. It comes pre-provisioned with accounts that you can use in your development workflow. And then some other things you can do is like generating types and publishing objects to IPFS. The second context that Taqueria operates in is as a VS Code extension. So for the VS Code users in the room or listening online, via the command line palette, you can do Control-Shift-P and start typing TAQ, and you'll get a nice list of the different capabilities of Taqueria and what it can do for you in the context of your project. So this makes it quite nice and discoverable. So new developers or seasoned developers can find out what's available in the tool and in the project. And again, you can do things like compiling all your contracts, reloading your application, managing your sandboxes, listing your accounts. And we have the beginnings of a user interface in VS Code Extension 2. So modest today, but it's starting out. So the Taqueria extension UI will show you what contracts you have provisioned in your project. You can compile them from right there in VS Code. And it'll also give you a list of the environments defined in your project. And that could be for development, for sandboxes, maybe a testing environment, which could be on a private net or a test net. And you can do sandbox lifecycle management as well, so starting and stopping sandboxes. And you can also get a list of the plugins provisioned in your project. The VS Code extension is going to grow quite quickly. We've got a lot in store on that end, especially for the developer feedback cycles. So one of the frustrations that developers have when building in a sandbox is you originate contracts in here, and you can't really see them visually unless you go querying it with curl or other tools, and because you typically don't have public indexers for sandboxes. They only exist on testnets. So we're hoping to address that need. The third context that Taqueria operates in is CI/CD. And this is a little bit outside the realm of developer workflow experience, but there is a big overlap in needs here. And this is our effort, again, to lower the barriers for developers to build their projects with mature, modern software engineering best practice. So for every release of Taqueria, we publish an updated GitHub action, and you can use this GitHub action to get started and run your tests for your project directly in GitHub. And then you'll be able to also use this GitHub action to do deployment, the D in CD, continuous delivery. So when you make pull requests to your project, then you can have a preview build of your entire application on a test net or a private net, whatever it may be. So again, we want to reduce the barrier for people so they can get to this point, and this helps. It helps the developer as an individual or the team of developers. It also helps significantly for things like third-party auditors and testers. So it's intended to take a lot of mystery out of what's going on. So I mentioned that Taqueria is a plugin-based tool. And all of the capabilities that you will see in Taqueria, the majority of them are contributed to Taqueria by the plugins that are declared or included in your project. So the strategy we had with making an architecture for this tool and to make a plugin architecture be a very central part of it was quite important, like in my opinion. As I said, we have a very diverse and rich set of tooling in our ecosystem, and I don't think that's going to slow down. As we get more of these layer 2 solutions and roll-ups and so on, I believe we're going to have a Cambrian explosion of options and tooling within this ecosystem. There's going to be a lot of work, and there's going to be a lot of different ways that we interact with Tezos and layer 2s, and ways that we haven't even thought about yet. There's going to be some neat things built here. And so even if us as a team had if we wanted to hold dominion over building plugins and for it to be our thing to build for the community, which we don't, but suppose we did, we wouldn't have the capability to keep up with that Cambrian explosion of options and so on. So it was very important for us to build this plugin architecture and do it in such a way so that other teams can build plugins either for their products for the broader ecosystem, or teams can build plugins privately and use them within their private tooling and projects and so on. So Lego and SmartPy, these are two plugins that we've built in-house so far. I mean, the compiler plugin is essentially it's an abstraction over a high-level language. Archetype, thank you to Benoit and his team. Archetype was the first third-party contribution we had made to Taqueria. So they built a plugin for their compiler for it to be represented in the Tackeria story. And that was very welcomed by us. It sort of helps validate that we did an okay job of making an architecture where a third party could build a plugin without too much difficulty. Languages. So presently we have one language plugin that's based on Taquito, and presently Tackeria is useful really for dApp developers or developers that are building JavaScript, TypeScript applications in Node, or potentially other containers like Cordova and such. But we have architected Tackeria so that the language component is actually a plugin as well. And so this leaves the door open for us in the future to be able to add support for development in other languages. So there shouldn't be any major obstacles in us or somebody else to contribute, for example, a PyTezos plugin. And this is helpful for somebody who may be creating a Python service that interacts with a smart contract on-chain. Then we have a Flex Tezos plugin for Sandbox lifecycle from the wonderful Oxhead Alpha people. And this allows you to run a local Sandbox node or instance of Tezos on your workstation. And then some more, a new plugin that we recently published is IPFS Pinata. So this is very useful for people who are publishing contract metadata for their contract to IPFS, and or if they're doing tokens, they want to publish token metadata. So this assists in that workflow, and it reduces the amount of sort of like picky, finicky little things that developers need to think about all the time. Then type generation. I've got a couple of slides specifically about that. And then we have a Jest plugin as well for the testing story, which is, I mean, testing in blockchain is crucial. And in my opinion, it should be easier. So we're trying to help with this. So a bit more about code generation. And this part of Tackeria is again a plugin, but it's not depending on a third-party tool. It's implemented directly in the Tackeria plugin itself. And so in Tezos we have this beautiful thing called Michelson, which is a strongly typed language. It's the lowest unit of programming language you have in Tezos. You don't need to write that directly. But it does give us these strongly defined types. And what Taqueria does with these types is that it'll read these kind of Lispy S expressions that are, to the computer scientists here are, second nature, but to the not computer scientists here is like, ooh. And so it takes a type definition, such as the one here on the left, and it'll produce a TypeScript type definition, which you have on the right here. And so this helps significantly with the developer experience when you're writing applications for Tezos. You get IntelliSense style code completion. If you end up passing a value of a wrong type, you get redlining, and you get compilation errors. So this helps significantly, and with Taquito and the methods that get populated for a smart contract, those methods have traditionally not been strongly typed. And so that's something we observed by listening to our users and seeing what our users do with entry points. They have to really figure out, how do I compose a parameter for this sort of complex data type that is a parameter that goes into this entry point? And there's a kind of a lot of figuring that out. So these types help significantly on that end. And we've added support for generic types in Taquito that consume these. This is so it makes it a lot easier. And then integration test stub generation. So when you have a smart contract, it may have one or many entry points, as an application developer, you want to write integration tests so that you can see that your contract is behaving as expected over time, and you want to be able to run these integration tests again and again and again, especially as things change. So your smart contracts could depend on other smart contracts. And also, as protocols change as well, you want surety that your application is continuing to run against the next latest and greatest protocol. And protocols generally, they're forward compatible. They don't have breaking changes. But you still need to check. You still need to be sure, especially if you're building an application or a DeFi system, for example, that's dealing with substantial amounts of value. So the test stub generator tool, it generates a lot of code that's all essentially boilerplate. All these tests are failing assertions, so the responsibility is still there for the developer to come in and actually implement the assertions around their logic. Do I get an error returned in this case where I expect to have an error, and looking for all those corner cases. So this really should help testers get to the point where they're actually writing tests actively, and it's not sort of an afterthought or something that gets deferred. And when you're new to a blockchain and you're like, okay, how do I test this? And you open up a test file, like test.spec.ts, and it's like, okay, what am I going to write here? So this gets you started. This gets you tests that run, happen to fail, but it gets you going. So at the core of Taqueria, we have something that we've been spending a lot of time on building, and we're continuing to build it, is the Tackery Estate Api. So the state API allows us to define assets or objects within our project, and they could be smart contracts. They could be public utility contracts, so that don't exist in your project, such as oracles. They could also be IPFS objects. And so all of these objects, they have unique identities in different contexts. So if you deploy a smart contract to a Sandbox, you're going to get a KT1 address, and that address is going to be unique in that smart contract. That's not portable into your testnet. When you redeploy this into your testnet, you have different identity. And so what we see time and again is developers hard-coding these values throughout their code. And this creates an enormous amount of friction for the developer just alone. If it's a one-person developer, just moving this from one environment to the other, it becomes it becomes difficult. It also doesn't help with third-party reviews by testers or auditors, because it's like, oh, this is hard-coded to your environment. Now you have to go and figure out all of this other stuff. And they're spending a lot of time on housekeeping and figuring this out, instead of doing the work that they're skilled and good at, and technically what they should be getting probably paid for. So by using the state API, we can refer to all of these assets, be they smart contracts or IPFS objects, symbolically. And when we go to redeploy our application into a testnet, it should all just work. And the state API models all of this as a graph, a dependency tree. So your application will typically depend on a smart contract. Your smart contract may depend on some IPFS objects. And then you may have circular dependencies as well. And so during your developer workflow, if one of these things changes, there's a chain of events there that need to invalidate that graph. And you need to redeploy the right things. Now, you can redeploy it all again, but then that's slowing down that developer feedback loop. So the Tackery Estate API will help to speed up that feedback loop by deploying the objects that need to be redeployed. And this sort of speaks to some of the DevOps principles that we have, and especially like infrastructure as code, that systems should be reproducible, they should be easily testable, and processes should be reproducible. And yeah, I've spoken to some DeFi teams in the ecosystem, where they have to send an operation that updates some aspect of their DeFi protocol. And I can tell you right now, I mean, that line of DeFi work, I'm not cut out for it. I would sweat bullets. And they tell me that, it's like, yeah, we're very nervous when we do this. We do all this testing and again, but it's tedious and it's hard to get it all put together. So what we're hoping as a promise from Tackery is that we're going to make these type of tasks reproducible, so that it's not all down to one hero developer, that a team can help. And a software developer, engineering and test, for example, can easily take a project, run it from scratch, and validate that these changes are what we expect them to be. And yeah, the promotion of your application between testnets as well is a very, very important one. I've touched on this already, but I want to emphasize it. Is having to deploy your application to a testnet and get it all running. The cost of that is pretty high. And in our feature testnets, and prior to GhostNet, which is a long-lived testnet, we had a bit of a participation problem in that the effort it took for teams to deploy their application to the new testnets was quite high. And teams are all, they're not solving the problem of testnets and so on. So they're doing what they need to do in their context. And so we had this low participation from ecosystem tools and so on, and ecosystem projects for getting them to deploy their applications into testnets. So this is really like something that we want to improve, and we want to make that process much easier. And if Taqueria is well used, these patterns become reproducible. There's equity built within users. They get familiar to say, okay, this is familiar. This, I run tac deploy all, and everything builds and everything deploys. You don't have to figure out what the last developer was thinking. You don't have to get inside their head. Yeah. So, in summary, it's a developer tool suite for application developers. Not just a smart contract developer tool suite, but it's tying together that whole asset pipeline from smart contracts, applications, and all of these other third kind of off-chain tendrils. We're aiming to tie together all these wonderful tools from the Tezos ecosystem. We've built plugins for some of them. We're going to build plugins for more. I've personally learned about a lot of tools this past couple of days that I'm really excited to represent here. And you guys are welcome to build plugins too. It runs in those three contexts: the command line, VS Code extension, and CI/CD. And we're hoping that we built it in such a way that if VS Code isn't your editor of choice, you should be able to fairly easily build a plugin for yourself, for if you're a Vim or an Emacs user or whatever else. We try to generate, we do generate TypeScript code for types to make that developer experience friendlier and safer, as well as integration test stubs. And we give you a common surface or a common action to be able to compile smart contracts, even if you have a project with mixed smart contract languages. So if you do tac compile and you have a smart pilot contract registered in your project, a Lego contract, and an archetype contract, it'll compile all three. So that abstraction reaches down into the compilers for those respective tools, and it produces Michelson for you. And then it aims to do compile, deploy, test, improves that feedback loop, and allows you to refer to your contracts by name across sandboxes, testnets, and mainnet. And it'll also help you with deployment orchestration. So your deployment orchestration is normally a multi-step process, and when all of those steps sort of work reliably, that's great. But when one fails in the middle, where do you restart? Do you have to restart from scratch? And we hope we allow you to define those multi-step processes in code, and that ties in with the infrastructure as code, deployment scripts as code. So, special thanks. There's a list. Thank you to the Tezos Foundation. I mean, they have a long-term vision, and their support is greatly appreciated for this ambitious project. To the TezDev organizers, I'm really impressed with the quality of this event and the production, like all the details. I mean, they even painted the walls for us. Our early adopters, who've provided feedback and testing, as well as the teams that sat with us and we were able to interview before we even built this project, because we reached out and spoke to a lot of teams to understand their pain points, sort of taking that product management approach. Our wonderful peers in the Tezos tooling ecosystem, there's so many of you, and I'm not going to name names because I'll invariably leave somebody out, but yeah, the tooling ecosystem and, I mean, the ecosystem, the community within Tezos is wonderful, and it's one of the core reasons that I'm working in this space. It is really a wonderful community. And finally, to the bold and curious developers, you guys, exploring Tezos, we can't wait to see what you guys build. And you can find Taqueria on our website and also our GitHub project, and you can follow the Twitter handle, Tezos Taqueria, where we'll be posting product updates, release notes, and we'll be doing a lot more community engagement by fortnightly office hours as well. So we want to connect more with the community now that this project is at a point where developers can start checking it out. So that's the end of my TED talk. Thanks for coming.
Questions?
Do we have time for questions? Yeah. Carlos.
Hey, thank you very much. It was great to hear that. You said something about people forget to deploy their contracts on the new testnet. And is it that I can use the GitHub integration to kind of schedule the redeployment of those contracts to the new spawning up test networks, and to get like a notification like, oh, your build failed, I think there's a new testnet and you should check out the contracts? So that's a wonderful idea, and but not quite my point in this case. But you probably could do that. What I was trying to get at there is that it's not just the deployment of the smart contracts, but the complete project. So let's say you have a DeFi application or an NFT marketplace, and I'm not calling anybody out here by any means.
These are just examples. It takes effort to get that redeployed onto a testnet because there's a lot of intricate, picky work to make sure that all the pieces are correctly in place and that you have a web application that's published on some sort of testnet preview URL, and that application is referring to the correct contract on net. And if your application relies on some other public application that hasn't shown up yet, then you're blocked. So not only is it generally like a tedious for development teams to redeploy those things onto the different testnets, it's when they get there, if the other tooling and if the other applications in the ecosystem haven't shown up yet, you're blocked, and then the value of actually getting there is sort of diminished. So what's the point? And so we want to make that less tedious and less error prone and just easier to quickly reproduce, rebuild. So redeploying your application to a testnet should ideally be just a few commands on the command line, as opposed to plumbing together like a lot of different things. Yeah.
Thank you for the presentation. Imagine that you have followed the rules. You have deployed on testnet, you did everything as the best practice of the software engineering asks you to do. You deploy on mainnet, and then after sometimes your contract is stuck for some reason, but you don't understand why. Is it possible to retrieve enough context and reject it in the testnet to debug, actually?
Mm-hmm. Yeah, that's a good question. I think what may help in that situation is having good test coverage, integration test coverage for your smart contracts, where you make assumptions of how your smart contracts should exist on the testnet and the state that they should be in. And so with the integration tests, you can read a lot of data and make assertions that it's how you expect it. So instead of doing a manual kind of debugging process of looking at the storage, does it exist to this, and this? Ideally, you'll have that suite of integration tests. And hopefully, through this tool, that will make it easier to write those. And so those integration tests could do things like, query the storage for your contract. And let's say your contract lists some Oracle address. Then you may want to assert that Oracle address is actually an address that exists in this context, in this testnet. And if it doesn't, then you have quick feedback about why. So hopefully that can help. Did I answer your question? Maybe. Mm-hmm.
So you didn't write a test to catch this behavior?
I mean, maybe there's more. So the question, the follow-on question was, an engineer has deployed their system to a testnet, and some unknown parameters have caused it to not work. I mean, on mainnet, okay. Okay, so so yeah, so some context in mainnet may have changed. Let's say we're referring to an Oracle that stopped working, or some of the mainnet constants have changed over time. So so I think a portion of your question may be talking about unknown unknowns, and by definition we can't know those. But I think to come back to the integration tests, if the engineers can create integration tests that are truly portable, then they can run those integration tests as possibly even continuous monitoring. So integration tests are often considered to be something that you run on pull requests as changes are made. But if they are portable, then there's less friction, and there's a possibility of running those integration tests in your production environment. And you can probably run those on a cron job. And hook them up to a monitoring system. So then, if your contract does depend on some oracle that stops getting a data feed, then you can get alerts from that. So possibly. Okay. Good question. Any more questions?
So the tool Taqueria is a bit like Truffle for Ethereum, right?
Yes. Yeah. So it's equivalent it's sort of equivalent in the Ethereum space, could be considered to be Truffle or Hard Hat, and it is aims to fill that use case.
Okay. And we have seen this morning the presentation of Factoria. Is a bit the same? Are you collaborating together? Or?
Yeah, so we've started. We've met the Functori people this week, and we're very excited about what they're building. There is some overlap, but I mean, I think there's a bigger opportunity for collaboration here that we're really excited about, yeah, by working together, and that's something I love about this ecosystem again as well, is that there are many teams that, if you boil it down to capitalist sort of ideals, they're competing against each other, but that competition doesn't really come up. We're all working for the broader goal of Tezos, and to grow adoption, and for Tezos to produce some meaningful social change.
Okay, thanks.
Okay, any more questions? Excellent, I'm done.